Okay, so let's get started. So as previously discussed, we have a lot of devices in the future that will allow us to track our health data remotely. This data is of interest of different stakeholders, healthcare providers, researchers, companies, for various of reasons. But how do we ensure that this data is transferred securely between the different parties? And how do we ensure that you have the control of your data so that privacy concerns are upheld? In this presentation, I'll talk about blockchain and how that might be able to help facilitate the data transfers between different parties in a safe way. So this is a simple explanation of how today's system works. And one of the challenges that we have in the sort of the patient journey is that data across different healthcare providers, meaning hospitals, private practices, etc., they all run their own database systems, which makes it difficult for data sharing. In fact, you often need in the US to go and have paper forms signed at every hospital to transfer the data to the specific specialist, and that also occurs in Europe as well. So in terms of data transfer in the future and sharing all of this valuable healthcare data, I've come up with four main challenges. The first is like, how do we ensure data privacy? You are in control of your data will not be abused. How do we ensure data consistency? When we share data across multiple stakeholders, how do we ensure that the data isn't duplicated and that every party work together to the largest extent? How can we facilitate data enrichment? And data enrichment is when you collect different data pieces together, and as a whole, it becomes much more valuable. And within healthcare, you can imagine a lot of separate data sources will allow combined for a better diagnosis. And how do we ensure permissions and locking of those permissions for data transfers? And that's a super critical key, because right now EU regulations will fine companies up to 5% of their revenue if they don't abide to the data privacy laws, and doctors can lose their accreditations. So right now you're signing personally different forms, and that creates slow data transfers, because everything has to be processed with a certain due diligence before data is shared, and that's both bad for like treatment, especially in critical situations, but also gives a bad user experience for the patient, as there's a larger delay and involvement in terms of data sharing. So why is blockchain interesting? And I hope most of you already know about the blockchain, but I've sort of mapped out three components that I think are very interesting. So every user in the blockchain have a private key and a public key, and the public key enables others to communicate and see who you are, whereas the private key can be used to store sensitive information. And by having the private key, you're the only one who can decide who gets access to this data, and you can also use the private key to shut this data off. Another interesting part of the blockchain is that it's a peer-to-peer database, meaning that all these different healthcare providers and apps and researchers could all access one database that logs all the permissions about who has access to what. And this gives the legal foundation for quicker data transfers, as paperwork and third parties and due diligence is not a requirement. And a final part is that everything is timestamped. So in the blockchain, you'll be able to see when somebody gave permission, but also when the permission was annulled. And that is also something that is a property that's very interesting, especially because the blockchain is more or less indestructible. Now, there are edge case scenarios in which data can be erased, but generally it's like a file sharing system like we've seen with Pirate Bay and so forth, where illegal files are transmitted. It's very tough to shut down. It's very resilient because it's a system in which you need to hack more than 50% of all the nodes in order to change it. And as it's a decentralized system, potentially with a lot of users, that's a lot of computers to hack. I don't want to get too much into that, but that's also very important as we're dealing with very sensitive information. So if this database is very secure, it's a very important property in this case. So I don't have long, unfortunately, to explain the blockchain and how it can bring value. But essentially, by using a blockchain, you as the user with your private key would grant access to data instead of you having to go to different healthcare providers and fill out forms and have third parties ensure that data is transferred. That's both, I think, more fair because you're in charge, but it also makes the process faster. Now, it will also synchronize permissions as everyone is accessing one centralized, or it's not a centralized, but one central database that's shared peer-to-peer. So companies who are permitted to get access from other providers will instantly be able to see when this happens. And because it's all digital, you can even imagine that some of these permissions could be self-executable, meaning that no IT person would have to be involved with sending the data. Then it's time-stamped both for permissions and transactions, and is important for regulations. And then it's also it's much faster, as explained earlier. And the regulations is a key part, as also mentioned, because EU will even remove the accreditations of doctors and take up to 5% of a company's revenue if the privacy laws are not upheld, meaning that data is collected or stored that is not allowed or permitted by the user. So that was a quick explanation about why blockchain could be a great way to manage data, especially data sharing in the future. I hope you enjoyed the presentation, and I look forward to seeing you next week.